All right, we're going to talk about vectors addition. Actually, it's very simple as adding the x-coordinate and adding the y-coordinate. But there's different ways. The first way is the parallelogram method. So you add the two vectors and they have share that common point. On page 543, they have a picture of what it's describing. And we're going to go ahead and do that. To find the common vector, here it says use the parallelogram method to add the two vectors. All you do, add the x-coordinates, add the y-coordinates. So here, so if we have vector A and vector B, if we were to add them, that means you add the x-coordinates, so that means it's going to be 2 plus 4, comma, and then you add the y-coordinates, 3 plus negative 1. And when you do that, you get 6 comma 2. You don't have to put these arrows on it. If you put 6 comma 2 on your homework like that, that's completely fine. I prefer it this way than that way. And that's the answer for the first one. Example 2, the second method that we use is called the head to tail method. That means it works with things that are 2 or more. The first one only works with just 2 vectors. This one's going to work with a variety of different vectors. So here, let's say if we have a triangle, we have vector v, vector w. To find that point where it's an open shape. To find that last point where they all close, you have to add the vectors. So here we have 3 vectors. It doesn't create a triangle, it's not vertices, it's vectors, so it's a whole line. On your book on page 544, they show you a picture, but for the sake of time, I'm not going to show you. So to find using the head to tail method, all you're doing is you're adding all the vectors. So C plus D plus E. So vector C, vector D, vector E. You add up all the x-coordinates and all the y-coordinates. So the x-coordinate, 5 plus negative 2 plus negative 1. That was all the x-coordinates. Now, I'm going to add up all the y-coordinates. 4 plus 3 plus negative 1. I always put parentheses between my negatives so I don't get mixed up. Now, we go ahead and add 5 minus 3. So negative 2 plus negative 1. 5 minus 3 is 2. 4 plus 3 is 7, minus 1, 6. And that will be your answer for the second one. Pretty simple, just add or subtract. Here is now we're going to apply both methods and we're applying the magnitude. It's a right triangle, and here they're going to give you vector A and vector B, 6, 0, and vector B is 0, 4. Here it says find the magnitude, and the degree here, it says find the magnitude in the direction of the resultant vector. So that's just right here in the corner. I drew it out in my graph here. I have the number of units here. My vector for this one is 6, 0. And remember, when we count for triangles, we count the number of units away. So 6, 0, this vector will look like that. That's 6 units away. 1, 2, 3, 4, 5, 6. And then the other one was 0, 4 after the second vector. So 0, or right here, and then goes up 4. So in this case here, it's actually 0, 4. And then it goes up here, it's 4 units away. So there's 1, 2, 3, 4 units. So that's why I have a 4 there. And that's why, when I simplify it, I have A being 6 squared plus B being 4 squared. And this is equal to A plus B squared. Vector A plus vector B squared. Now, we go ahead and simplify. The absolute value, remember your answer is always positive. So that means this will be 36 plus 4 squared is 16. And this will give you A plus B squared. It's not C. You're dealing with vectors. So that means the combination of the two when you add them. You combine them, you get 52 equals the absolute value of A plus B squared. To get the measurement, we have to square both sides to get the absolute value by itself. So now the measurement there, so the absolute value of A plus B is going to be about 7.21. So the square root of 52 is about 7.21, and that's considered your magnitude there. So your vectors here will equal to about 7.21. Now we have to find the magnitude. The magnitude here is that degree there. Like I said before, when we were dealing with the triangles, we were counting the number of units. Vector A was 6, vector B was 4. When you're trying to find the degree, you use inverse trigonometry, like what we did last time. So from this, the vector A, or 6, in relation to that degree symbol, it's adjacent, and 4, in relation to that degree, is considered opposite. And what symbol uses both? That's the tangent. So the tangent of theta, which we don't know, is equal to opposite, which is 4, over adjacent, which is 6. And from here, you don't put a tangent of 4 over 6. Keep in mind, we're trying to find the degree. When you're finding the degree, you use inverse. So the inverse tangent to both sides, and that's how you can get your inverse, or your theta by itself. And then if you do the inverse tangent of 4 over 6, it's in your calculator, you have to use second and then sine, cosine, tangent. So inverse tangent of 4 over 6, you get about 33.7 degrees. That's the angle for this here. Last one, example 4, it's a word problem. Here it says a plane has traveled a horizontal distance. It can be represented by the vector 8,000, 0, and vertical with the vector of 0, 4,000. Here it says what magnitude of the distance, what is the magnitude of the distance is traveled to the nearest meter. So now we're going to try to find this, and I put as x, meaning we're trying to find for it, trying to solve for it here. So now we have to find the magnitude. Keep in mind, it's like triangles, we have to think of Pythagorean theorem. So now we have to know that it's one side squared plus the other side squared plus, or is equal to, the sum of the two squared. And I'm labeling that as x. So if you add these two, since we have numbers for them, all we have to do is add them, and we'll have our vector here. So again, we're dealing with triangles, and it's a right triangle. We have to find the magnitude. There is absolute value symbols with magnitudes. So now it's the first one. So it's 8k. I'm gonna put 8,000 squared plus 4,000 squared, 4k, just to make it easier. I hate writing all the zeros down. Now you go ahead and simplify. So 8,000 squared gives you 64 million. I'm not going to put it, it's too many zeros. Plus 4,000 squared gives you 16 million. So you get 64 million plus 16 million is equal to the absolute value of x squared. Make sure you add everything before you go ahead and square. 64 million plus 16 million, you get 80 million is equal to the absolute value of x squared. Now, to get the absolute value of x by itself, you square both sides, and then x is going to be about the square root of 80 million, so you have to put all of those zeros there. You'll get about 8,944.27, and that rounds to the nearest meter, means you're rounding to the nearest number here. You get 8,944, and that will be your answer. Need any more help, let me know. My email is down there. Have a good day.